Hello, my name is Ryan Schumacher, and I'll be presenting my project on coral health improvement for my food quality management course. The following slides comprise the analyze and improve phase of my project. My original problem statement was that my Montipora digitata coral is currently in a poor state of health. Been very little growth and actually some die-off in the last 3 months. Typically these corals are actually pretty hardy and grow rather quickly. My goal, I've actually updated. Of course, I'm going to identify the optimum growth environment, water parameters to eliminate die-off and create visible growth, but I'm actually increasing that due to, as you'll see later on, that I had better growth than I thought. So I want to get more than 7/16 of an inch growth from here until the end of the project, which is a 25% improvement. As a refresher on how I measured my coral growth for my project, I used a camera to take pictures weekly, had the cameras placed in front of a grid to get the scale of the picture. I then analyzed the photo in Photoshop and measured it in pixels of growth, and then was able to take that pixel and convert it over to an actual inch measurement. Using the previous measurement method, I measured the baseline performance of my growth. It was totaled out to be 0.15 inches over a period of 3 weeks, which was equated to 0.05 inches per week. My goal, knowing that I actually am getting some good growth, even more than what my original problem statement mentioned, is to actually improve that by 25%. So total growth from here on out over the next 7 weeks would be 0.4375, 7/16 of an inch, which would equate to 0.0625 or a 1/16 of an inch per week. This slide shows the baseline performance growth of my coral, showing week 0 on the left and week 4 on the right before I made any improvements. To measure temperature and pH of my tank, I'm using a Neptune Systems Apex Aquarium Controller. It's a compact logic controller. It's got inputs and outputs for various measurements such as temperature, pH, and outputs to control outlets such as heaters and tank lights. It logs the data, and it's actually connected to the internet to give me information. The temperature and pH probes are mounted in the tank, and they record every 10 minutes. Data is then logged and stored in the controller so I can retrieve it at a later time. And the reason I'm actually measuring pH is because there's a link and correlates to my dosing regimen of alkalinity and calcium. To analyze the temperature control of my tank, I created an individual moving range chart. You'll see the center line in black at 77.5 degrees, control limits in red lines, and the upper and lower spec limits in green lines. You notice that the capability index is 1.16, which means it is capable, but not extremely capable. As you can see, I've got a couple spikes above the control limits there on the left-hand side of the chart due to some warm days in the house, since my tank does not have chilling. However, because it is fairly in control and none of the points really were detrimental to the tank, based on basically industry standards for tank temperatures, I chose not to use this as something to improve on. This is my analysis of pH data. Again, center line is in black, control limits are in red, and specification limits are in green. Capability index is 1.06, so this is just barely capable of a process here. You do see I do have a couple spikes outside of the specification limits. However, those are just kind of anomalies due to placement of my pH probe and really close to where I add my high alkalinity solution in the tank. And you can see it quickly comes back down once the solution has a chance to circulate in the tank. So because it's at least barely capable, I chose not to look at this further for improvement. To measure both alkalinity and calcium, I'm using a Hanna Checker colorimeter, and it uses a fixed wavelength LED and a silicone photodetector to actually measure the color change that is due to chemical reagents. You can see a little bottle that I've got water mixed in, and you put the chemical reagents in there, it causes a color change, close the cover, push the button, and it gives you a readout of what the value is. This is my analysis of the alkalinity process capability. I used, again, IMR charts to analyze this. Center lines, upper lower control limits are labeled on the charts. For these, my upper and lower control limits are equal to my upper and lower specification limits. Had a capability index of 1.04, so it is capable, it is within control. However, literature says that I should have my alkalinity at a level of about 9 to 9.1, where it's actually at a 7.3, so this is the one aspect that I did choose to improve upon. This is my analysis of calcium process capability, again using an IMR charts here. Center line, upper lower control limits are labeled. Again, upper and lower control limits are equal to upper and lower specification limits. This one, capability index, is actually just a little bit below 1. However, because I appear to be pretty much within my control limits most of the time anyways, and the center line is right at 426, which literature says it should be about 420, I chose to, again, focus on my alkalinity readings for improvement. Here's my cause and effect diagram, or fishbone diagram. You can see my original problem statement on the right side there. You can see the major ribs of the fish are the 4 parameters that I'm kind of looking at closely: alkalinity, temperature, calcium, and pH. A lot of what you'll see here, if you pause this presentation, just take a moment to look at it, is mostly values that are either too high or too low, out of the range of good temperatures and alkalinity ranges for the corals. And then you'll see other things such as too much fluctuation, or the interaction, as I described earlier, with my auto top-off and spikes in those values. This is my process failure mode effect analysis table. It's an attempt to put a risk priority number and objectively quantify the problems that I'm already talking about addressing with the tank. As you can see, my auto top-off roll there, it was 105, one of the highest values there. That one I've already identified that I'm going to try to fix by working on raising the alkalinity in the tank. And then you can also see the tank lighting at the bottom being a high number, which was a just do it. I just replaced the bulbs on that light to help. This is a slide showing the improved portion of my project, focusing on the alkalinity using IMR charts with upper and lower spec limits equal to control limits. Not very well in control. Capability index is a 0.33, which is very poor. A lot of lines above and below my control limits. So you can see, on the left side there, where it was low, about a little over 7. On about October 22nd, I started trying to shift from 7 points of alkalinity up to trying to get to an average of about 9. So you can see I had a really big spike in it there for a while, and then I had to slowly let it kind of come down naturally on its own. And then you can see where I dosed more alkalinity again, and it kind of spiked up, slowly came down. And you can see over time I was able to slowly get it back in control and narrow it down, but by that point it was a little too late. And as we'll see later on, I think it had adverse effects on coral growth. Here you see my coral growth over the improved stage of my project. Week 4 on the left, which is where I left off at the measure phase, and then week 10 on the right. It looks like some decent growth, but as we look at the numbers on the next slide, we'll see that it wasn't quite meeting my goal. Here's the calculations for my improved stage of my project. I had a total growth of 0.217 inches over a period of 6 weeks, which equals 0.036 inches per week, which is about a little over half of what I wanted for my goal. It's actually worse than what my baseline performance was. One attribute of that is because of the alkalinity problems I had that I explained a couple slides ago. This is a summary of my theories tested. First one was water temperature, at which I found the process to be in control and capable after analyzing the data. Same was true with my pH. Alkalinity was one of my big upsets with this, as I tried to raise the alkalinity to 9.0 from an average of 7.3 on my baseline performance. I overshot the target, and it took me time to get up the process variable actually settle back down and get in control. I think this caused a lot of reduced growth rates because of that instability in the process, and then created a process that was not capable. The calcium levels of the water, I said were in control and capable enough for what I was doing, and I wanted to really focus on alkalinity anyways. The other problem I had that isn't really shown in data here, but the light fixture I have actually broke on me in early November, and what ended up happening is I couldn't get enough light on the tank and control it well enough, so I think that also kind of set back the coral growth for a while there until I got it fixed. As you can see my project schedule, I'm now most of the way through the analyze improve stage. From here on out, my future plans would be to keep focusing on getting that alkalinity measurement in control and see if over the next couple of months I can get some better growth going on there. Just due to the slow coral rate, it's kind of hard to get data quickly. This concludes my presentation, and I'd like to invite everyone's comments and questions and constructive feedback. If you can leave that in the post, that'd be great. Thank you.